OCR FSMQ Advanced Level Additional Mathematics, June 2014. Question 1. Solving the following. Minus 6 less than 2x minus 1 less than 7. In this case, we need to add 1 to all of it. So minus 6 plus 1 less than 2x less than 7 plus 1. Minus 5 less than 2x less than 8. Now we need to divide all by 2. Minus 5 over 2 less than x less than 8 over 2. And therefore, minus 5 over 2 less than x less than 4. Question 2. The gradient function of a curve that passes through the point 1, 2 is given by dy dx equals 3x squared minus 4x plus 7. Find the equation of the curve. If you have a gradient and you wanted to find a function, you integrate. And if you go in the reverse order, you differentiate. Now, with integration, if you have y equals x to the power of n, then the integral of y dx will become x n plus 1 over n plus 1 plus c. So that's the definition of integration. We've been given a gradient, dy dx equals 3x squared minus 4x plus 7. Multiply both sides of the equation by dx. Dy equals 3x squared minus 4x plus 7 times dx. Now we need to then apply integral. Dy equals integral 3x squared minus 4x plus 7 dx. But integral dy is also equal to integral y to the power 0 dy, because y to the power of 0 equals 1. So we have integral of y to the power 0 dy equals integral of 3x squared minus 4x plus 7 dx. And that implies that gives us y equals if you apply the integration rule, so you get integral of, I'll just take that integral sign off, so you get y 0 plus 1 over 0 plus 1, because n is 0 in this case. And that equals integral, take the integral off, so that equals 3x squared plus 1 over 2 plus 1 minus 4x 1 plus 1 over 1 plus 1, because x to power 1 equals x, plus 7x to power 0 as x to power 0 equals 1, plus 1 over 0 plus 1 plus c. So in this case, we're going to get y equals 3x cubed over 3 minus 4x squared over 2 plus 7x plus c. And that becomes x cubed minus 2x squared plus 7x plus c. And that's the function. But we need to find c when x equals 1 and y equals 2. So x equals 1, y equals 2. If you put that back in, so I get 2 equals 1 cube minus 2 into bracket 1 squared plus 7 into bracket 1 plus c. 2 equals 1 minus 2 plus 7. Therefore, I get 2 plus c. Therefore, I get 2 equals 8 minus 2 plus c, which implies that 2 equals 6 plus c, and therefore c equals minus 4. And therefore the function we're looking for is y equals x cubed minus 2x squared plus 7x minus 4. Find question 3i. Find the area enclosed between the curve y equals 8x cubed, the x-axis, and the line x equals 2. You could solve this question by first of all sketching a graph. You don't have to sketch the graph to solve the question. And the curve 8x squared will be more like that. And the line x-axis, so x-axis there, minus x, and the line x equals to 2. So if that was 2 here, so that line x equals to 2 is this one here. So the boundary will be between 0 and 2, and we want to find the area under that curve. And this is your y-axis, and that's your minus y. So the area we want to find is area under the curve here. And in order to do that, we know that y equals to 8x cubed, and the area is integral y dx within the boundary of 0 and 2. And that will be equal to integral of 8x cubed, because that's what y is, dx 0 and 2. So in order to carry on doing this, so that's the area. Now, integrating that would be using the definition of integration, which is y equals x to the power of n, and integral of y dx will be x n plus 1 over n plus 1 plus c. So that's what we're applying here. 8 is a constant, so you could take the 8 out and just do integral of 0 to x cubed dx. And then you get 8 square bracket x to the power of 4, 3 plus 1, over 4, 3 plus 1, plus c, close square bracket, and the boundary 0 and 2. So I have now got 8 x plus 4 over 4. Let me just use these 8 into bracket 2 to the power of 4 over 4. I've substituted 2 as the x value, plus c, minus, put in a square bracket, 0 to the power of 4 over 4 plus c. So those are the values of the boundary applied when x is 2 and when x is 0. So we take them away for the definite integral. And now I get 8 into bracket 2 to the power of 4 is 16 over 4 plus c minus 0 minus c, and that c cancels out, so I get 8 times 16 over 4, which gives 2 times 16, 4 here 1, 4 here 2, 2 times 16, and the area is 32. So area is 32. Question 3.2. Hence, or otherwise, deduce the area between the x-axis, the y-axis, and the line x equals to 2, and the curve y equals 8x cubed plus 5. Well, we just found the first one with y equals 8x cubed, and that area turned out to be 32. Now there's a new addition to that curve, which is y equals 5. Now if we integrate y equals 5, remember that will become y equals 5x to the power 0, and integral of y dx will become 5x to the power 0 plus 1 over 0 plus 1, and that should give us 5x. Now there's a boundary for this integration, obviously 0 to 2, and plus c, by the way, and so plus c, and then we put 2 to 0, and so that area for the constant y equals 5 will become 5 into bracket 2 plus c minus 5 into bracket 0 plus c, and that should give us 10 plus c minus c, and that becomes 10. So the new total area for y equals 8x cubed plus 5 will be will be 32 plus 10, which is 42. Question 4.1. A train travels from station A to station B. It starts from rest at A and comes to rest again at B. The displacement of the train from A at time t seconds after starting from A is s meters, where s is equal to 0.09 t squared minus 0.0001 t cubed. 1. Find the velocity at time t seconds after leaving A, and hence find the time taken to reach B. Give the units of your answer. Well, so we got a displacement given to us, s equals 0.09 t squared minus 0.0001 t cubed. If we differentiate the displacement, we'll get velocity. So if you write the s, the t, that will give us the velocity, which is v, and that equals 0.09 t squared minus 1, 2 times minus 3 times 0.0001 t cubed minus 1. So I've just applied the differentiation formula, where you have y equals x to the power of n, and the x will be nx n minus 1. So in this case, what do I get? I get 0.18 t, because 2 minus 1 is 1, minus 0.0003 t squared. And that's the velocity. But the final velocity is 0. The final velocity is 0. So therefore, we need to equate this to 0. So I get 0 equals 0.18 t minus 0.0003 t squared. In this case, t is common. So I'll write 0.18 minus 0.0003 t, as a taking t out, equal to 0. And so therefore, from here, t equals to 0. That's the first solution. And the second solution will be 0.18 minus 0.0003 t equal to 0. And so what I need to do now is move 0.0018. So I have, actually move minus 0.0003 t to the other side. So I get 0.18 equals 0.0003 t. Now I need to divide both sides by 0.003 t, 0.0003, and I get t equals 0.18 over 0.0003, and that gives me 600 seconds, and which is, if I divide it by 60, I get 60 minutes. Question 4.2. Find the distance traveled between A and B. Give the units of your answer. Well, there are two times, t equal to 0 and t equals to 600. At initial time t equal to 0, s is equal to 0. From the formula, s equals to 0.09 t squared minus 0.0001 t cubed. If I substitute t into the equation, I get s equal to 0. Now I need to find s when t equals 600. So now I need to substitute t equals to 600. So s equals 0.09 600 squared minus 0.0001 600 cube, and that will give us 32400 minus 21600, and that gives 10800 meters, which equals 10.8 kilometers. So the displacement, or the distance traveled between A and B is 10.8 kilometers. Question 5i. A ship is moving on a bearing of 025 degrees at 14 knots. 1 knot equals 1 nautical miles per hour. As it passes point A, a lighthouse L is seen on a bearing of 340 degrees. After 30 minutes, so first of all, this is our 25, so that's 0 to 5 degrees, and the bearing from the lighthouse is this one here, which is 340 degrees. After 30 minutes, the ship passes point B, from where the lighthouse is seen on a bearing of 320. So 320 will start from there and go all the way to there. So that's 320 degrees. Find the angle BAL, and the angle ALB. So that's angle ALB, and then we need to find BAL. To find angle BAL, which would be, so this, if that goes from 340, take away 360 from 340, I get that angle there to be 20, because I go for 360 minus 340 is 20. So I can write it down. So that angle is 20 because 360 minus 340 equals 20 degrees. Now to find angle BAL, so angle BAL is 20 degrees plus 25 degrees equals 45 degrees. Now we need to find angle angle ALB. First of all, we need to find angle, to find angle ALB, we need to find angle angle ABL. So let's find angle ABL. Okay. So let's find angle LBN should be equal to, well, 320. So if I take 360 and minus 320, I'll get 40 degrees. So the angle LBN will be 40 degrees. Right. Therefore, to find angle LBA, that should be 180 minus 40 minus 25 degrees. That will be equal to 115 degrees. So the angle LBN is 115 degrees. Now to find angle ALB, we need to take away from 180. So the 180 minus, right, 45 minus 115 degrees. And that will give us, so 180 minus 45 degrees. So that should give us 20 degrees. So angle ALB is 20 degrees. Question 5.2. Hence or otherwise calculate the distance BL in nautical mile. Best is to draw this diagram. Let's just draw that properly. And that's L. Let's make that A. I'll draw that again. This angle here is 115. Let's call that L, B, A. And this is 45 degrees. Let's assume this is 20 degrees. Now, L, so this side here, AB, is for 30 minutes, and 14 knots is 1 hour. And therefore, we travel for 30 minutes, so that would be 14 over 2, so that's 7. The distance here is 7 because it's 14 over 2. Now, the distance LB is what we're looking for. Let's call that little a. And the AB, should we call that little l? So we can use sine rule, which says that A over sine capital A equals L over sine capital L. Now we know what A is. Little a is what we're looking for. So A equals L sine capital A over sine capital L, which is 7 sine 45 degrees over sine 20. When we plug that into calculator, we get 14.5. So the distance traveled is 14.5 nautical miles. Therefore, LB equals 14.5 miles. Question 6.1. The function fx equals x cubed minus 4x squared plus ax plus b is such that 3x equals 3 is a root of the equation fx equal to 0. When fx is divided by x minus 1, there is a remainder of 4. Find the value of a and the value of b. So what we need to do is to find the factor root first. So when x equals to 3, I get 3 cubed using the equation given, 3 cubed minus 4 3 squared plus 3a plus b equal to 0. In this case, I then get 27 minus 36 plus 3a plus b equal to 0. And therefore, I get 3a plus b equals 9. So that's my first equation. When x equals 1 from x minus 1 equal to 0, therefore x equals 1, I get 1 cube. Let me just write this clearly so it's not confusing. So put it here. When x equals 1, so I get 1 cube minus 4 into bracket 1 squared plus a1 plus b equals 4. Not 0, 4, because that's what it says with the remainder. Now, and when I simplify this, I get a plus b equals 4 plus 4 minus 1. Therefore, a plus b equals 7. Now, I get these two equations now, so I need to solve them simultaneously to find a and b. So the first equation is 3a plus b equals 9. The second equation is a plus b equals 7. So if I take away, solving them simultaneously, equation 1, equation 2, if I solve it simultaneously, 3a minus a is 2a, b minus b is 0, and 9 minus 7 is 2. Therefore, a equals 2 over 2 equals to 1. A is 1. From equation 2, we know that a plus b equals 7. When a is 1, I get 1 plus b equals 7. Therefore, b equals 6. So I need to plug a and b back into the function. Fx equals x cubed minus 4x squared plus x, because a is 1, 1 times x is x, plus 6. Question 6. Solve the equation fx equal to 0. So we need to solve fx, which is x cubed minus 4x squared plus x plus 6. We need to solve that by equating it to 0. Right. So, in order to solve that, let's just write it out first. X cubed minus 4x squared plus x plus 6 equal to 0. But we do remember that x minus 1 is used with a remainder. Is used to divide, and then we got a remainder equals 4. So we don't need to use that. We know one of the factors. One of the factors is x minus 3, and that gives fx equal to 0. So we need to use that. And the way to use that is to either divide the function by x minus 3. So we could do that and to find the other factors. So we could do x minus 3 divided by x cubed minus 4x squared plus x plus 6. The reason why we're doing this is to find the other factors. The factors will then give the solutions. So we need to use x squared to get x cubed. X squared times x will give you x cubed. X squared times minus 3 will give you minus 3x squared. So we need to take away minus 4x squared minus, that's plus. So that will give us minus x squared. Obviously, minus x cubed minus x cubed is 0. And so we need to bring down the x. So we need to multiply x minus 3 by minus x. Minus x times x will give us minus x squared. Minus x times minus 3 will give us plus 3x. So now we need to take away again so that we can get rid of x squared. Minus x squared minus minus, which makes it plus, x squared, that will be 0, x minus 3x is minus 2x. Now we need to bring down the 6 plus 6. Now what can we multiply with x to get minus 2x? We want to use minus 2. So if we put minus 2 times x is minus 2x. Minus 2 times minus 3 is plus 6. So in this case, there's no remainder where we subtract. Minus 2x minus minus 2x is 0. 6 minus 6 is 0. So no remainder. So now we know the factors. The factors are x minus 3 and x squared minus x minus 2. What we now need to do is factorize that one. We need to factorize x squared minus x minus 2. In order to do that, we basically multiply the AC. AC is minus 2. 2. So we need to multiply AC. AC. A is let's just write it. A equals 1, there's a 1 here. And B equals minus 1, there's a 1 here. And C equals minus 2, and that's C minus 2. So let me just take them out. Right. Okay. So AC is 1 times minus 2. Any two numbers I can multiply together, I get minus 2. When I add them together, I get minus 1. So that would be, let's start with 1 and 2 minus. So if I replace that with an X and that with an X, and then I put that back into the function, so I get X squared minus plus X minus 2X minus 2. So I've replaced that with this. And therefore, I'll still get minus X because plus X minus 2X will give me minus X. Now I can factorize, common factors here. X is common, I get X plus 1. Minus 2 is common, I get X plus 1. Therefore, the factors, the common factors are, so let me just draw a line here. So the common factors are X plus 1 and X minus 2. And then the total factors for this function will become X minus 3 equals X cubed minus 4X squared plus X plus 6. So these are the common factor here. X is a common factor, X plus 1, that's what that is here. And then you're left with X minus 2, and that's what this is. And then I added the final factors, which is that one here, and that's where you get that. So now I know the solutions are. The solutions when I equate it to 0, so X plus 1, X minus 2, X minus 3 equate to 0 will become X plus 1 equal to 0, which implies X equals minus 1. So that's the first one. And the second one is X minus 2 equal to 0, and that implies X equals 2. And the third one, X minus 3 equal to 0, that implies X equals 3. So the solutions are X equals minus 1, 2, and 3. Question 7. The point A and B have coordinates 3, 7, and 5, 11 respectively. And that's A and that's B. Find the exact length of AB. To find the exact length of AB, we need to use, basically, if that was A and that was B, and I drew my coordinate there, this is what I'll get. And my coordinate B is 5, 11, and A is 3, 7. So the distance, all I needed to do is find this distance here, the height, and so basically I need to use Pythagoras theorem to find AB. The distance here is going to be y2 minus y1, and this here is going to be x2 minus x1. And the coordinates that you've got here are x2, y2, and this is x1, y1. So I'm going to use those values in order to find my AB distance. So the distance AB, so AB squared is y2 minus y1 squared plus x2 minus x1 squared as this is my point 1, that's my point 2. That's why I'm using 1 and 2. Now, y2 is 11, so that's 11 minus y1, 7 squared plus x2 is 5 minus 3 squared, and that gives us AB squared again, which is 4 squared plus 2 squared, and that's AB squared. Now I need to add them together. 4 squared is 16 plus 4, that will be 20, and that's AB squared. Therefore AB will be root 20, and root of 20 is root 4 times 5, which equals root 4 times root 5, and root 4 is 2, so that's 2 root 5. So that's what AB is. So what I did was square root both sides to get AB. Question 7.2. Find the equation of the circle with AB diameter. If the equation of the circle, so if I draw a circle just to show you what I meant, and this is AB, the diameter, let's just draw a proper diameter. So if that was AB, the center here will be the radius, point of the radius. So that's the center for it. So that means we need to find the midpoint of AB. And to find the midpoint of AB, you need to use, remember A has a coordinate 3, 7, and B has a coordinate 5, 11. So I need to find the midpoint of these two. Midpoints are x2 plus x1 over 2, comma, y2 plus y1 over 2. So that's how you find the midpoint. So the midpoint will be x, so that'll be 5 plus 3 over 2, comma, 11 plus 7 over 2, and that gives us the x midpoint is 8 over 2, which is 4, and this one is 18 over 2, which is 9. So the midpoints of the circle are 4, or the center of the circle is 4 and 9 coordinate. And the equation of a circle, because we're told to find the equation of a circle, the radius is going to be, the radius of this circle is going to be, if AB equals, let's just write it clearly, two root 5, therefore the radius will be equal to a half AB, which is root 5. Now, what we need to do now is to find the equation of the circle, which says that x minus a squared plus y minus b squared equals root 5 squared. But a is 4 and b is 9. So we can write as x minus 4 squared plus y minus 9 squared equals 5. So the equation of the circle is x minus 4 squared plus y minus 9 squared equals 5. Question 8.1. 4-point half coordinate A, B, C, and D. Using gradients of lines, prove that ABCD is a parallelogram. If parallelogram, then the opposite side must be parallel. Meaning same gradient. So I've got point 1, point 2, 3, 4. So let's look at AB. AB must be parallel to CD. Hence, they will have same gradient. Now referring to the points again, point 1, point 2, another point 1, and point 2. So let's find AB gradient. Which is y2 minus y1 over x2 minus x1. And y2 is 4 minus 1. x2 is 0 minus 5. That will give be 5 over 5, which is 1. So let's find CD gradient. Again, using y2 minus y1 over x2 minus x1 be equal to minus 2 minus 3 over 2 minus 7 will give minus 5 over minus 5, which is 1. Because the gradient is the same, since both gradients equals 1, hence parallelogram. Using length of lines, prove further that ABCD is a rhombus. Rhombus have equal sides. Therefore, AB must be equal to BC. So we could find AB, which equals to square root of y2 minus y1 squared plus x2 minus x1 squared Now we know A is, if we look at the coordinates of A, that's minus 5 and minus 1, and B coordinate is 0 and 4. So this is x1, y1, x2, y2, and therefore we will get square root 4 minus 1, that will be 5, so that will be 5 squared, and the x will be 0 minus 5, that will be another 5 squared. So AB will be equal to square root 50, which gives root 25 times 2, which becomes root 25 times root 2, which is 5 root 2. Now BC, let's find BC. BC, so point C, let's look out for point C. C is 7, 3. So this is now, this is the new x2, y2, and this is now x1, y1. And that will become square root y2 minus y1 squared plus x2 minus x1 squared. And that will become, now y2 is 3, so 3 minus 4, that will be 1, so that will be root 1 squared, and x2 is 7 minus 0, that will be 7 squared, and that gives us root 50, which is same, which is 5 root 2. So because they're the same, AB, since AB equals BC, hence it's a rhombus. Question 8, part 3. Prove that ABCD is not a square. If it is a square, then the normal will have a gradient of minus 1 over the tangent gradient, MT. Or you could say m normal, gradient of normal, times the gradient of the tangent will be equal to minus 1. So we need to find the gradient of AB. We know what that is. We've done it before. AB gradient equals 1. BC gradient must be, if it's normal, minus 1 over 1, which is minus 1. So let's find the gradient of BC. We know the coordinates of BC again. 0, 4 for B, 7, 3. So B is 0, 4, and C is 7, 3. And the gradient y2 minus y1 over x2 minus x1. x1, y1, x2, y2. And that will give us 3 minus 4 over 7 minus 0. And that becomes minus 1 over 7. So therefore, m AB, gradient of the AB equals 1, and the gradient of BC is not equals minus 1. Hence, it is not a square. Question 9. 1. We need to show that 1 minus cos squared x over 1 minus sine squared x equals tan squared x. But remember, sine squared x plus cos squared x equals 1. Therefore, I can rewrite 1 minus cos squared x equals sine squared x, and 1 minus sine squared x equals cos squared x. Now, if I have 1 minus cos squared x over 1 minus sine squared x, that should be equal to sine squared x over cos squared x, which becomes sine x squared over cos x squared. So square is a common factor. So that would be sine x over cos x all squared, which meant that, but we know that sine x over cos x equals tan x. Therefore, sine x over cos x squared must be equal to tan x squared, which is now equal tan squared x. So 1 minus cos squared x over 1 minus sine squared x equals to tan squared x. Question 9, part 2. Hence, solve the equation 1 minus cos squared x over 1 minus sine squared x equals 3 minus tan x. From the last expression identities, we saw that 1 minus cos squared x over 1 minus sine squared x equals tan squared x, which is now equal to 3 minus 2 tan x. So what we're now looking at is tan squared x plus 2 tan x minus 3 equal to 0. If I let tan x equals y, therefore, and I have y squared plus 2y minus 3 equal to 0. Can I factorize this one? Yes, I can, because my a equals 1, b equals 2, c equals minus 3. So my AC will be equal to 1 times minus 3, which is minus 3. Any two number I can add together, I'll get 2. When I multiply, I get minus 3, so I get 3, 1. Put minus in there. Turn that into y. And that's y as well. So 3y minus y will be 2y. So I can replace 2y with 3y minus y. So I go y squared minus y plus 3y, that still gives me 2y, minus 3 equal to 0. Common factors, y minus 1 plus 3, y minus 1 equal to 0. Y plus 3 is a factor. That's common. So I got y minus 1 is also a factor. What's left? Y plus 3. And that equal to 0. We need to set these two to 0. So y plus 3 equal to 0. Therefore, y equals to minus 3. Y minus 1 equal to 0. Therefore, y equals 1. So I now need to find the value of, let me just move this away. So now I need to find the value of y. Y equals minus 3 is tan x equals minus 3. So tan x equals minus 3. So what is the value of x? And that implies that x equals tan to minus 1, 3. So shift inverse tan, 3, minus 3 by the way. Shift inverse tan minus 3 is minus 71.6 degrees. Minus 71.6 degrees is the value of tan in this case. What about when tan equals, when y equals 1? That gives us tan x equals 1. Therefore, x equals tan inverse 1. So tan inverse 1 is 45 degrees. So that will be x is 45 degrees. Now we need to find the range between 0 and 180 degrees. So the first angle we just found, I'm going to draw a circle. So I'll draw two circles. Drawing again. Now the first angle we found, should draw a straight line there, was, let's look at the 45-degree ones. So that's 45. In this first quadrant, there's a first quadrant there, all is positive. Sine is positive here, tan is positive, and cos is positive. Now, tan 45, I'm going between 0 and 180 degrees as recommended. So the reflection of that is here, which is, just draw that one there. So if that was 45 here, so this one here would be 135 degrees. Sine is positive here, but I'm looking for tan. Tan is negative in the second quadrant, so that's first, just to remind us again. So that's the quadrant here. That's the first quadrant, second quadrant, third, and fourth. So all is positive in the first quadrant. Sine is positive in the second quadrant. Tan in the third quadrant. Cos in the fourth quadrant. But we're only going between 0 and 180 degrees. So therefore, we only stay in the top part of the quadrant. So the first angle that we needed was x equals 45 degrees. It's the first one that's positive, because the value of tan is positive. Tan x equals tan x equals x. So that's positive. So that's accepted. The second, and then the 130 degrees, it's actually, tan is not positive at that point, so tan is negative, so that's not required. For the second value, when tan x equals -3, I get -76. So if I draw a circle for that one, right, so I get -76, 71.6. Now here, and it has a reflection there. To be honest, actually had an extension that goes up that way. So vertically opposite angle, so this one is 71.6 degrees, which makes this angle between there and there 108.4 degrees. So that's the angle we needed. We're going from between 0 and 180. But yes, in the second quadrant, tan is negative, but the value of tan x that we got is also negative. So because it's negative and tan is negative in the second quadrant, that's acceptable. So we needed x to be also equal to 108.4 degrees. So those are the two values that we needed. In the range of, in the domain of 0 degrees is less than or equal to x, which is less or equal to 180 degrees. The angles are x equals 45 degrees and 108.4 degrees. Question 10.1. Find the coordinate of the point P on the curve y equals 2x squared plus x minus 5, where the gradient of the curve is 5. So we got the equation here, the function 2x squared plus x minus 5. If I'm going to write this so that I'm ready for differentiating this, because I need to find the gradient, and the gradient is differentiation. And the gradient, the y dx equals 5. So I need to write this properly to help students to see this. So that will be 2x squared plus x to the power of 1 minus 5x to the power of 0. Remember, x to the power of 0 equals 1. So that's why that was 5. Now I'm ready for differentiation now. Well, if I have y equals x to the power of n, my dy dx will become n x n minus 1. So we just apply the formula, applying that rule. So let's apply it here. Dy over dx becomes, well, 2 is already a constant, so I'll just leave that there, times 2x 2 minus 1. So plus 1 times x 1 minus 1 minus 5 times 0 x 0 minus 1. So what do we get after this? We get the y dx equals 4x to the power 1 plus 1 x power 0 minus 0, because 5 times 0 is 0. And that becomes 4x plus 1. So that's the y dx. And that actually equals 5 from the question here. That equals 5. So we can solve for this to find the coordinates. 4x plus 1 equals 5. Therefore, 4x equals 4, which implies that x equals 1. When x is 1, plug that back into the equation to get y. So we know y equals 2x squared plus x minus 5. When x is 1, so I'm going to plug that in, so I get y equals 2 into bracket 1 squared plus 1 into bracket minus 5, which gives 2 times 1, that's 2, plus 1 minus 5, and that will become 3 minus 5 equals minus 2. So when x equals 1, y equals minus 2. That's the coordinate at the point when the gradient is 5. Question 10.2. Find the equation of the normal to the curve at the point P. Right, so we just, from the normal, so what that meant is, just to remind you, the gradient is that one. If that was the gradient, let's call that mt, and that equals 5. The normal is a line perpendicular to the tangent. That's what's called normal. And the gradient of the normal, let's call that mn, the normal, that has to be a relationship that says mn times mt, the tangent, has to be equal to minus 1. That's the relationship between normal and tangent. So that's what we're going to do here. We know the gradient of the tangent equals 5. We can find the gradient of the normal now, but just rewriting it. So m normal equals minus 1 over mt, which equals minus 1 over 5. So that's the gradient of the normal. At the coordinates, we know the coordinate where this happened. So what we now need to do is to find the equation for that. Y minus y1 equals m into bracket x minus x1. So that's what we use. At what point? The point of when x equals 1 and y equals minus 2. So that was the point we found earlier. So that point is here. 1 minus 2. So that's the point we're going to use in this general equation here for finding the equation of a gradient, with equations with coordinate and one gradient. If you have one coordinate, so if you have a coordinate like that, that's one coordinate, and you have a gradient, t in this case, which is 5, this is the best equation to use. Now let's use that and find the equation. So we know y minus y1. So y1 is this is your y1, and that's your x1. So y1 is minus 2 equals minus 1 over 5. That's your m normal, because we're trying to find the equation of the normal, into bracket x minus x1. x1 is 1, so that's just minus 1. Close bracket. Y minus minus is plus 2 equals minus 1 over 5 x minus 1. So all we need to do is multiply out the minus 5. That will become minus x over 5 plus 1 over 5. So just multiply by opening the bracket. I'll take 2 to the other side. Minus x over 5 plus 1 over 5 plus 2. So what I'm going to do is make all the denominator the same. So I'll just go equals minus x over 5 plus 1 over 5. That here is not plus, it's minus. And then minus, so 5 times 2 is 10, 10 over 5. Which means I have one common denominator now for this one here. So y equals minus x over 5. In fact, what can I just add all up together? So let me just add the numerator together. Minus x plus 1 minus 10 all over 5, because they all have the same common denominator, which implies that y equals minus x minus 9 over 5. So that's the equation. You can write it in two ways. Y equals minus x over 5 minus 9 over 5. That's the equation. Or you can write it as 5y equals minus x minus 9. So that's the equation of the normal, which can then be written as 5y plus x plus 9 equal to 0. Question 11.1. Color is making an open box out of a regular rectangular piece of card measuring 30 centimeters by 140 by 14 centimeters. She cut squares of side x centimeters out of each corner and turns up the edges to form the box. Find an expression in terms of x for the volume v centimeter cube of the box and show that this reduces to v equals 4x cubed minus 88x squared plus 420x. Now, the volume is area times height. And so we need to find the area. So we got V equals this distance here will be 30 minus 2x. So that distance here is 30 minus 2x. And that distance here is 14 minus 2x. And so the area will be 30 minus 2x times 14 minus 2x, and then times the height of the box, which is x. So area is the area we're talking about is this area here of this rectangle, the ones I'm just drawing. So that's the area of this rectangle. So if I draw it properly, so it'll be that length and that length, that length, and that one. So that's the area we're looking at. And then it's got an height of x, and that's what that is. So what we now need to do is do expansion. V equals 30 times 14 is 420 minus 30 times 2x is minus 60x. 2x times 14 is minus 28x. That's minus 2x times 14 plus minus 2x times minus 2x is plus 4x squared, all times x. So we need to simplify. So I get 420 minus 88x plus 4x squared, all times x. And that's V. So now we need to just multiply it all out. V equals 420 x minus 88x squared plus 4x cubed. So if we write it properly, V equals 4x cubed minus 88x squared plus 420x, and that proves the original equation. So I'm going to put Q, E, D. Now question 11.2. Find the two values of x that satisfy the VDX equal to 0. We know V equals to 4x cubed minus 88x squared plus 420x. Now if we do dv dx, now remember when you're differentiating, if you have y to power x to the power of n, it's got to be in that format. It's got to be in the format of the power of n before you differentiate. And now the y, the x will be n x n minus 1. And so we're doing the same thing here. We've got v, so we haven't got y, we've got v. So v to the power of xn. Therefore, the v, the x, will be nv x. Let me just take that back. nx n to the power minus 1. So we're going to do the same here. 4 is a constant, 88 is a constant, 420 is a constant. They're coefficients. These coefficients are constant. So therefore, what we're going to do now is differentiate, ignoring the constant. But you still use the constant, just ignore it when you're differentiating. So the 4 is there, so we're not going to do anything to that one. X cube, cube is n minus 1. So I need to, the cube, I have to bring it down here, bring it down. The n comes down. So you have to times it by 3. That's x. Then 3 minus 1. That's what that is. Minus 88 times 2, x, 2 minus 1. The next one is plus 420 times 1, x, 1 minus 1. So that's the differentiation going on there, because that's the power of 1. Now I can write it 12 x squared minus 88 times 2 is 176 x to the power 1 plus 420 x to the power of 0, which is just 1. As you know, x to the power of 0 equals 1. Because x to the power 1 minus 1 is x to the power of 0. So that's the v, the x. So what we now need to do is to, because we're told to find the two values, so we need to solve it. Why has it got two values? Because it's got two values because the degree of polynomial is 2. And because the degree of polynomial is 2, it will have two values. It will have two solutions. And that's what it meant. If the degree of polynomial is 3, it will have 3 values. So let me take that circle out. So the exponent is 2, which means the highest power, the highest exponent is 2, and the degree of polynomial is 2. Hence, it's got 2 values, 2 solutions. Now, what we need to do is find those values. And in order to find the value, we equate this to 0. So we'll try and solve it. So therefore, we got 12x squared minus 176x plus 420 equal to 0. I need to divide the whole thing by 4. I can see 4 goes in there. So 4 goes in 12, that's 3x squared minus 4 goes in 176, that will be 4, because 4 times 4 is 16. 1 left, carry that forward, that will be another 4x, so 44x. Plus 4 goes in 4, that's 1. 4 goes in 25, but because it's 420, so 0, 5. So that's, and then 0 divided by 4, that's 0. Now, to factorize this, the best thing to do is to apply the factorization process where a equals 3, b equals minus 44, and c equals 105. 3 times 105, that's AC. So I'm going to put AC here so I can have room for my calculation. AC is 3 times 105, that's 315. It's a plus. Bring it down. What two numbers can I multiply together to get 315? And when I add them together, I get minus 44. So a bit difficult. You have to go through a bit of, you have to dissect these carefully, and you have to go through 1 and 315, and then 3 and 300. And then, so you have to go down slowly. But after going, I finally found that 35 and 9 are the good numbers. So I've got 35x and 9x, but I need to make them both be negatives. And in doing so, minus 35x minus 9x will give me minus 44x. So that's good. So I can replace minus 44x with minus 35x minus 9x. And that's the point of this, is to do that. So I got 3x squared minus, let's go for 35, minus 9x would be the best thing to go for here, minus 9x. Because 9 and 3 are kind of, it's easy to factorize 9 and 3. So I'll put them together. And then I minus 35x plus 1 whole 5. It's easy to factorize minus 35 and 1 whole 5 because they can't go well together. So you put those two together, go to 0. And when I'm factorizing these, I get 3 as a common factor. I get 3x, sorry, may I take that back? 3x is a common factor, so I get x minus 3. That's one there. That's what's left from those two, the first two terms over there. Now I can get minus 35 out, and I get x minus 3 as well. This shows I'm doing well because that and that should be the same. Minus 3 and minus 3, that's good. That's the same. So that's good. Equals 0. And therefore the factors are 3x minus 35 and x minus 3 equal to 0. And that implies x equals 3 and x equals 35 over 3. So those are the solutions for the two values of x. X has to be equal to 3 and x has to be equal to x has to be equal to 35 over 3. How do I get that? Obviously, I need to set 3x minus 35 equal to 0. So you always set the factors to 0. And therefore, 3x equals 35. X equals 35 over 3. You set x minus 3 equal to 0 as well. X equals 3. And that's how you get those values. Question 11, part 3. Explain why one of these values should be rejected and find the maximum value of the box using the other value. Well, so we know the values we're talking about here. The values that we got earlier, which is x equals to 3 and x equals 35 over 3. And that would be 11.7. Now, 11.7 will be rejected because it is over half of 14. So this is over half of 14. It's impossible to turn into a box in that sense. So hence, it's going to be rejected. But the one that will be accepted will be x equals 3. So for x equals 3, writing down the equation again, 4x cubed minus 88x squared plus 420x. So all I need to do is replace x with 3. So I'll go v equals 3 cubed minus 88 3 squared plus 423 bracket. In this case, all I need to do is multiply them out. V equals, well, 3 cubed is 27. 27 times 4 is 108 minus 88 times 3 squared is 99. 99 times. Question 11, part 3. Explain why one of these values should be rejected and find the maximum value of the box using the other value. Well, the two values we got earlier were x equals 3 and x equals 35/3, which will give us 11.7. So those are the two values. The reason why 11.7 will be rejected is because 11.7 is half, more than is over, let's just say over, is more than half of 14. And that's why it will be rejected. And the other value that will be accepted, V, is x equals 3, where V equals 4x cubed minus 88x squared plus 420x. All I need to do is substitute x for 3. So I get 3 cubed minus 88 3 squared plus 423, not x, 23. Now 420 times 3. So now what we need to do is multiply them out. 3 cubed is 27. 3 times 3, 9. 9 times 3, 27. Times 4 is 108 minus 9 squared is 3 squared is 9. 9 times 88. You may need a calculator for that one. So that gives you 792 plus 420 times 3. That's 1260. Always use calculator in a calculated aloud exam to make sure you get it right. Don't try and do it off head and get it wrong. Now V will be, when we do the calculation, it should be 5760. And that's these. And if you could use any value in this case. For V has a range between 0 is less than x and it's less than 7. That's the value for the maximum value of V. So that'll be 5760. Question 12.1. Paul walked from any town to next town, a distance of 15 kilometers. When he got there, he then walked back. His average speed on the return journey was 2 kilometers per hour, less than on the outward journey. Let Paul's average speed on the outward journey be x kilometer per hour. The time taken by Paul for the whole journey was 6 hours. Write an expression for time in hours taken for the whole journey. Right. Well, so first of all, we know that distance or speed is distance travel over time taken. And in this case, I have x, or sometimes you can call it v or u. X equals 15 over t, and therefore the time t will be equal to 15 over x. X minus 2, because it's 2, the average speed of the journey is 2 kilometers less than the outward journey. So x minus 2 will be equal to 15 over t. So this is the time for forward journey. And so the time for backward journey will be 15 over x minus 2. So the total time now for these journeys, traveling, is the total time will be equal to x, let's go back, will be equal to the time forward plus time backwards, which will be 15 over x plus 15 over x minus 2. So that will be the total time journey in terms of x. Question 12.2. Use the expression in 1 to form an equation in x and show that it simplifies to x squared minus 7x plus 5 equal to 0. Right. So this is a part 2, 12 part 2. So from the expression we got earlier, and for the fact that the total time taken by Paul for the whole journey equals 6 hours, and we just worked that out. So the total time, as we can find out, is 15 over x plus 15 over x minus 2 equals 6. That was the total time for the journey. As you can see here, it says the total time taken by Paul for the journey is that. And we've already worked out the total time here. And so we just equate it to 6. Now, what we need to do is basically simplify this expression. The common factor is x into bracket x minus 2. So I have got 15. Well, I've got x and x minus 2, the common factor, because I haven't got x minus 2 in the actual, so I have to put on top here x minus 2. Plus, I got 15 over x into bracket x minus 2, but I haven't got x here, so I have to put x there. Equals, 6 over x minus 2, but I haven't got x minus 2 here, so I have to put x into bracket x minus 2. So that's how I simplify it. Now the whole denominator is the same, so we can cancel all those out because there's an equal sign. If there's an equal sign and then the whole denominators are the same, you can cancel them out. So just apply the numerator, which is 15 into bracket x minus 2 plus 15x equals 6 into bracket x and x minus 2. So now we do the expansion. I'll do 15x minus 30 plus 15x equals 6x squared minus 12x. Now all I need to do is collect all the like terms together. So I've got, so let me move all the left hand side to the right hand side. So I got 6x squared minus 12x minus 30x plus 30 equal to 0. So let's finish this. 6x squared. Now 30 minus, so that would be minus 42x plus 30 equal to 0. Now what's common here? 6. 6 is common, so I get x squared minus 7x plus 5 equal to 0. Q, E, D. So I'll finish proving that's a proof of that one. So that's proof there. Solve this equation to find Paul's average speed on the outward journey. Now the equation we're talking about is this last equation we derived, which is x squared minus 7x plus 5, and that equal to 0. So we need to solve that equation, and in doing so, we need to solve this. We can use formula. If you're using formula, we have a quadratic equation, which is ax squared plus bx plus c equal to 0. Therefore, x equals to minus b plus or minus square root b squared minus 4ac, which is the discriminant, over 2a. So we could use that here to solve this equation. We couldn't factorize it, so we could do that here. So let's do that. A equals 1, b equals minus 7, c equals 5. So we plug those values in. X equals minus 7 plus minus square root minus 7 squared minus 4 into bracket a, which is 1, and c, which is 5, over 2 times 1. And that becomes 7 minus times minus is plus or minus square root 49 minus 7 squared is 49 minus 4 times 5 times 1, which is 20, over 2. And that gave us 7 plus or minus square root 29 over 2. And that gives us 7 plus or minus root 29 all over 2. So that's x, and the first x solution is 7 plus root 29 over 2, and that gives us 6.19, and x2 will be equal to 7 minus root 29 over 2, and that gives us 0.81. So the speed, Paul's speed, equals 6.19 kilometer per hour. Question 5.4, part 4. Find the difference in time between the outward and return journeys. Give your answer to the nearest minutes. Difference implies take away or minus. So the outward journey time minus inward journey time, which is equals to 15 over x minus 2 minus 15 over x. And that becomes, which implies that 15 over x is 6.9119 minus 2 plus or minus 15 over 6.19. And that gives us 15 over 4.19 minus 15 over 6.19, and that equals 3.58 minus 2.42. So the difference is 1.16, which equals 60 minutes plus 9 minutes and 36 seconds, which is roughly 1 hour 10 minutes. Question 13. 1. A company needed to buy 2 storage units. There are 2 types of units available, type X and type Y. The cost of each unit, the floor space required, and the volume of storage are given in the following table. The maximum cost allowed for the purchase of the unit is £1,200, and the maximum floor space available is 18 meters squared. The company wants to maximize the volume of storage. Let X and Y be the number of each type of unit, capital X and capital Y, respectively. Write down the inequality for the total cost and the inequality for the total floor space. In this case, question 13.1, we've got 100x plus this 100x plus 120y, and that should be equal to, the cost should be less than or equal to 1,200. We also have 2x plus 1.5y, which should also be equal to or less than 18. So that's the inequality equations. Part 13, part 2. Draw inequality you gave in part 1 on the grid provided in the answer booklet. Given that the x is greater than 0, so those are the conditions, x is greater or equal to 0, and y is greater or equal to 0. Indicate the region for which the inequality hold by shading the areas that is not required. So basically we need to plot these graphs and then shade the areas that are required. So the equations we're plotting are, first of all, I'll just write it on the left hand side here. We've got 100x plus 120y equals or less or equal to 200. And if I take 100 and divide both sides by 100, I'll get x plus 1.2y is less or equal to 12. The other equation is 2x plus 1.5y is less or equal to 18. So we're going to plot these two. In order to plot these two, we need two 2 points to plot a straight line. For the first one, we need x equal to 0, y will be equal to, with x is 0, y, x equals to 0 for the first one here, the first equation there. Let's call that equation 1. So for equation 1, when x is 0, y is 12 over 1.2, which equals to 10. And when y is equal to 0, x is equal to 12. So those are the values that we need to plot. So when y is 0, x is 12. So that's 12 here. And when x is 0, y is 10. So we got those equations. So all we need to do is draw the line. That's the line. Now the next equation will be for equation 2. So for equation 2, so I'll put that here. This is equation 2. Now for equation 2, when x is 0, y is what? When x is 0, y is 1.5y equals 18. Therefore, y equals 18 over 1.5. And that gives y to be, when x is 0, y is 12. When x is 0, y is 12. So that's that one there. When y equal to 0, 2x is equal to 18. Therefore, x equals 9. X equals 9. So all we need to do is draw that one to 9. So the shaded area will be these points here. So the part that is not shaded is where the inequality holds. For the volume for storage, and find the combination of units that should be bought to maximize the volume of storage. Write down this maximum volume. Well, we know that 3.5x for the volume plus 3y is the volume provided. So here's the one here. And so now what we need to find out is, look at the coordinates 0, 9, 0, and 0, 10. Those coordinates are here, 9, 0, and 0, 10. So the inside of the equation, so that's 9, 0, and 0, 10. So that's where the inequality holds. So what we need to do is test for those. So 3.59 plus 30 will be equal to 31.5. And we need to test for the 0, 10. 3.5x is 0 plus 3 times 10. That will be equal to 30. We also need to look at this point here. So another point is here, 6 and 4. So if we look at 6 and 4, that means x is 6. So this is x equal to 9 and y equal to 0, x equal to 0 and y equals to 10. So when I look x equal to 6 and y equal to 4. So 3.5 into bracket 6 plus 3, 4, and that gives us 33. Because 3.5 times 6, so punching that into calculator, 3.5 times 6 is 21. 21 plus 12 is 33. Question 4.1. Mugs are packed in boxes of 10. On average, 5% of the mugs are imperfect. A box of mugs is classified as unsatisfactory if it contains 2 or more imperfect mugs. State 2 conditions that must be satisfied for the number of imperfect mugs in a box to have a binomial distribution. So for a binomial distribution, the probability must be fixed, that is, remain constant. Number 2, imperfection of mugs are mugs independent. Independent of imperfection of mugs. Right. Question 14.2, part 2. Assuming that these 2 conditions are satisfied, calculate the probability that a box chosen at random is satisfactory. So P of 20% is 1 over 20, which is 5%, of 5%, which is 5 over 100. Now, Q will be 1 minus 1 over 20, which is 19 over 20. Or you could do 20 over 20 minus 1 over 20, and that gives 19 over 20. That's how I got 19 over 20. Now the probability of 0 or 1 will using the binomial distribution of n0 combination Q n minus r P of r. So that's a binomial distribution formula. Right, so that's what we're using. Now, what we need to do is to find a binomial distribution, in this case, for n is 10 and 0, and Q is 19 over 20, which is 10 minus 0, and 1 over 20, which is 0, plus 10, 1, which is 19 over 20, 10 minus 1, and 1 over 21. And that equals 10 combination, so that'll be 10 factorial over 10 minus 0 factorial of 0 factorial, which is 19 over 20 of 10 and times 1, plus 10 factorial over 9 factorial, 1 factorial, which is 10 minus 1. That's why you get 9 factorial, times 19 over 20 to power 9, 1 over 20. And then when we work this out, that will be 10 times 19 over 20 to power 10 plus, that's not 10, that's 1. So that's 1 times, plus this is 10. 19 over 20 to power 9, 1 of 20. So that will become 19, 20 to power 10 plus, by the way, 10 factorial of 9 factorial, 1 factorial is equal to 10 times 9 factorial over 9 factorial, 1 factorial. And that's why 9 factorial cancels, so you got your 10 factorial over 1 factorial. 0 factorial is 1, 1 factorial is 1. So that's why that equals 10. So that's a 10 here. So that's 10, 19, 20 times 9 to power 9, 1 over 20. And the answer to that one is 0.5987369 when you 7369 when you key into the calculator, and this is 0.3151 and what we get is P0 or 1 equals 0.9139. For P x greater than 2, we get 1 minus 0.9139, and that gives 0.086. .3. A shop received a delivery of a large number of boxes of mugs. The delivery is checked as follows. A box is chosen at random. If there are no imperfect mugs in the box, then the whole delivery is accepted. If the box is unsatisfactory, then the whole delivery is rejected. If there is exact one imperfect mug in the box, and then the second box is chosen at random, the delivery is accepted only if this box contains no imperfect mugs. Calculate the probability that this delivery is accepted. So for P to be accepted, that will be equal to P0 imperfection imperfect plus P1 imperfected times P0 imperfected. So that would be equal to 19 over 20 to the power of 10. That's for the P0 imperfected. We just worked that out earlier. Plus 10 for 1 imperfected. 19 over 20 to the power 9 times 1 over 20. 1, that's the 1 imperfected, times 19 over 20 to the power of 10 for 0 imperfected. And when we multiply all that together, when we add them together and key that into calculator, we get 0.5987 plus 0.1887. When we add them together, we get 0.7874. That's the probability that it's going to be accepted. And that's the end of the solution.